Good afternoon, and it's 4 p.m. on a Wednesday in June, and I'm the last technical talk standing between you and happy hour, or you and raffle draw for sure. So I'll keep this honest, useful, and on time. In the morning, we have the keynote by Corey. Corey opened this morning by saying that the urgency is always manufactured, right? And that good decisions pretty much wait for you, even when the loudest voices in the room insist that they cannot. And today, I want to spend the next 20 minutes underneath that idea that Corey had, because the architectural decisions that we're about to walk through are literally the place where, manufactured urgency does the most damage today. So let's get started. And I hope my clicker works. If not, it worked. So a few years ago, I was asked what looked like a simple question. If we needed to move this workload tomorrow, could we? And everyone in the room said yes. The application was containerized, the infrastructure was automated, the data was portable. And that was the assumption, So if applications are containerized and infrastructure is automated, then optionality follows. It's automatic. It's as simple as that. We're done. Let's go home. No. Well, that assumption is one of the most expensive things I've watched a smart team get wrong. And so, next slide. Boom. All right. 3 weeks later, after tracing the architecture end to end, we had our answer. Well, guess what? The identity was tied to cloud-native IAM patterns. Governance depended on organizations, the control tower, and config. Perfect. We had networking assumptions that were embedded in the hub and spoke designs through the transit gateway. And event flows, depended on events bridge. Infrastructure delivery like, CDK and, CloudFormation also depended on that. But notice what is not on the slide, what you're seeing right now. EC2 isn't the problem. Containers are not the problem. The application isn't the problem. The dependencies that matter actually live above the workload. And every one of those decisions was reasonable. None of those decisions were actually bad architecture at all. So the application was actually not the dependency. The platform was. And that was the line that literally changed how I think about every architecture decisions and every architecture review ever since. Containerizing the application solved a real problem, but it solved the smaller one. The dependency really mattered. All that really mattered was not really the application code itself, because that was portable, right? It was every decision that was sitting above it. Identity, network, governance, integration, delivery. All of it was AWS shaped. None of it was explicitly chosen. And so nobody really designed the lock-in. We designed leverage. Lock-in is just the side effect. And what bothered me was not really that we were using AWS services. I mean, those services, AWS services are delivering tremendous values every day. We've been in different workshops and sessions, and we can see how far it can go. But what really bothered me was that nobody had consciously decided which dependencies were strategic commitments and which were accidental. The organization really thought it was preserving flexibility, but in reality, it had been spending flexibility years over years by decisions, one decision at a time, without actually naming the trade, without anyone actually noticing what they were. Why are we doing this? What's the intent behind this? And so, well, like I said, my clicker stopped working. Okay, then it worked. Well, on this slide, as you can see, that experience that I just mentioned literally changed how I think about multi-cloud architecture. And the goal here is not to fear AWS native services. The goal is to use them with your eyes open. Because every service in your architecture today belongs somewhere within the spectrum that you see, right? The ones on the left are the commitments, accidental commitments, things that you never knowingly made. The ones on the right are commitments that you would make again, right? And decisions that are made in a week would actually determine your optionality 3 years later. And the next 8 minutes of this session are the 6 decisions that I've learned over time to be deliberate about. The ones where the difference between leverage and the difference between lock-in actually lives in. All right, so for our decision 1, we have identity. Identity, we have AWS IAM, we have Entra ID for Azure, we have GCP IAM, 3 identity models. All of them are powerful inside their own clouds. We all know that, right? Anchored identity means that AWS owns your own user records. So you create users in AWS, you provision the users in AWS, you deprovision in AWS. Your audit trail lives in CloudTrail. That works fine, perfectly fine. But until the day that you decide, or the organization decides that they need a second cloud, and you're not imagining 2 parallel identity systems that don't even talk to each other at all. What do you do in that situation? Federated identity. What does it mean? It means that your identity provider, just like you have Okta, Entra, Ping, or even your own SAML provider, whatever is the source of truth, AWS trusts its assertions. So does Azure. So does GCP. One offboarding, one query audits, one source of access truths across all of the cloud, AWS, GCP, or Azure. And so I ask, if AWS disappears tomorrow, what would your identity model survive? Will it be able to survive or will it die? And if the answer is no, then it means you've anchored. It means it's not federated. And it means that you've made a multi-cloud decision without actually knowing that you did. Okay, and so decision 2 is networking. Transit gateway is excellent. We have hub and spoke designs that are excellent. And here is the mistake that I would say I've watched smart teams made in the space of 15 years. They start using transit gateway. And then over time, when they describe their network architecture, they describe it as transit gateway terms. For example, attachments, route tables, transit gateway peering. Transit gateway vocabulary literally becomes the way they think about networking. That sounds harmless until the day someone says, we just acquired a company that runs on Azure. And then suddenly, you have to explain, your topology. And so what do you start to explain to a fellow network engineer? Oh, transit gateway, routing tables, and all of that. And so, at the end of the day, you realize that you're unable to actually describe what the network is doing because you have stopped distinguishing between the two. You're literally describing AWS-specific processes and not the actual thing. So the intentional version is simple. Draw your topology first in network primitives, right? So we have the hubs, the spokes, the segments, the trust zones, the egress points. That diagram is the architecture. Transit gateway is the implementation of that diagram in AWS. When Azure enters the picture, the diagram still doesn't change. The only thing that ever changes is just the implementation. And so it becomes very easy. Decision 3 is governance. We have control tower, we have organizations and config. These are some of the most powerful governance tools in any cloud. AWS has spent several years building all of this. Use them. We literally use them all the time. The mistake is letting your governance live inside their consoles. And here is what it looks like in practice. You're a security engineer or a DevSecOps engineer or whatever you are. And then you have to adjust a config rule within the user interface. And then 6 months later, your compliance officer asks why the rule was changed. There is no version history as to why. You can't explain that. There's no pull request. There are no review, no documented intent, and the rule changed because someone somewhere somehow clicked something, and you can't explain it. Now, multiply that scenario by hundreds of rules across dozens of accounts over the past 3 years. That is not governance. That is a configuration drift. And that configuration drift is pretty much dressed as a governance. And that intentional policy is pretty much what I call the policy as code. Service control policies live in version control. Config rules are code. The same governance intent expressed in a form that any kind of editor can read, any kind of engineer, even if it's a new engineer that is just hired today, they can review it, and any other cloud can implement. If you move to Azure tomorrow, or you include Azure as a multi-cloud or GCP, it's implementable. AWS is really where the policy runs today, right? But the policy itself doesn't mean that it belongs to AWS. And so the test is really whether, your auditor tomorrow, if you're working in the financial industry or pharmaceutical industry or healthcare, if they can read your governance from a Git repo, or maybe if whenever you have to take screenshots from the AWS console, can they read it? If it's the second one, then your governance is really anecdotal, right? And it's not evidentiary at all. And sorry, I have to click this severally. Okay, so decision 4 is the events-driven architecture. Events bridge. Events bridge is brilliant, absolutely brilliant. SNS, SQS, Kinesis, step functions. Those are some of the strongest event tooling in any cloud. And the mistake that I've watched a lot of smart teams make over and over, even one of the teams I've worked in, is that they start using AWS event services. And then over time, their understanding of what an event in their business starts to diminish. They start to not understand what an event actually means. It becomes tangled up with AWS services that are routing it. They cannot describe, okay, an order was placed without actually tracing it through an events bridge, without looking at the SNS fan out, without looking at the Lambda transformer. They can't do that. So the intentional version or the intentional design is really defining your event contracts first. The schema, the semantics, the ownership, the versioning, the retention. So what does this event mean? What does it actually mean? What does it contain? Who wants it? Write that down separately from any other AWS service. Then route it through Events Bridge, because Events Bridge is absolutely wonderful. Decision 5, we have IAC, infrastructure as code. We have CloudFormation, we have CDK, we have Terraform, all on AWS. Right? You can use Terraform on AWS. Terraform is not on AWS. All of these are powerful. Use them. But here is the mistake. You write 1,000 CDK constructs over 2 years. Your team becomes fluent in CDK. You onboard new employees, new engineers. Sometimes you have to teach them CDK, right? Then your delivery model has quietly become, oh, we're a CDK team. If you ever need to evaluate a different tool or deploy CDK somewhere else, it does not work well, right? And what's going on? You are pretty much rebuilding not just the templates, but the team's competence in that situation. And that is a lock-in. The code is not the problem, not the code at all. The team's brain is really where the lock-in is. So when you think about the intentional version, the intentional version is really treating the pipeline as the architecture. The pipeline is the key word. When you push a code via Git, it triggers gates, it triggers the security controls, the policy validation, cost preview, approval, audit login. And then the pipeline calls the deployment tool at the very end, right? The pipeline is what your team built expertise on. The tool is the part that you can easily swap, the very end. So pipelines really port across templates languages, but templates don't. So if you cannot today describe your infrastructure delivery without actually naming a vendor, then your delivery model is a vendor commitment. It's not an architecture. Decision 6 is the meta decision. So think of it. When do you lean fully into a cloud-native service? And when do you preserve portability? My answer after 15 years is that you lean deliberately, but with a tripwire. You lean in when you know that the service gives you a step change in capability or in velocity. We've had wonderful things today, and we've seen wonderful services that AWS offers today. DynamoDB, S3, Lambda, Bedrock for foundational model access. These are services that are like non-negotiable. These are services where the leverage is so significant that abstracting them away would actually cost even more than the lock-in, right? But every lean-in that we see right here, they all require or they all need a tripwire. A documented condition that, whenever it's triggered, would force you to revisit a commitment. So cost crossing a threshold, you have your SLA degradation, a regulator's question, an auditor's question, a leadership question, something you cannot answer, a geographic expansion that is the service that does not support. Without a tripwire, your intentional commitment is really indistinguishable from a drift. All right, so here is one number from an actual work. In one of the enterprises that I worked with, a large enterprise platform modernization, environment provisioning for a new team and workload went from about 4 to 6 weeks to under 24 hours. And that was a big deal. And it wasn't really because we shipped faster, no. But it was really, and it wasn't also because we hired like more engineers, because no, you know. But the real because and the real reason was because we finally stopped asking each team to make the same architectural decisions multiple times, anything more than twice. Governance, networking, event patterns, pipelines, all of those things were deliberate when we were architecting, and all of it is reusable, and all of it is all portable. And so that really helped us to reduce the number of hours of onboarding up to less than 24 hours. Okay, this is not clicking again. All right, okay. So, in a nutshell, why does this matter for multi-cloud? And this is because multi-cloud is the place where assumed boundaries fail the most expensively. Today, and multiple organizations have worked and currently working, we started with one cloud. For some reason, and for several genuine reasons, there are reasons where we need to bring in Azure or we need to bring in GCP. And every assumption that you make in just one cloud has to survive contact with another cloud's identities model, their billing model, their networking, their support process, their outage window, their compliance posture. And so today, I want to tell you that the teams that win really designed for that reality from day one, and the teams that failed assumed the boundary and got dragged into the consequence 3 years later, especially when they tried to move a new workload and then discovered that, no, we can't even move that workload anymore. So the biggest multi-cloud failure I've seen was really not vendor locking. Vendor locking isn't really the problem. It really is decision locking. That's the biggest thing I've seen. And so the organization still had multi-cloud language in their, strategy. Every time the architecture had quietly removed that choice earlier, even though they kept saying, we want multi-cloud. We are designing for multi-cloud. And so when we finally did the work in this scenario, the migration estimate wasn't measured in days in reality. It was measured in quarters. And not because AWS failed, because AWS did not fail. AWS was doing exactly what it should do. But because the architecture itself stopped being a choice. And you can kind of see as the line keeps going down, right? So multi-cloud is not a technology decision, really. It's a discipline of preserving future choices deliberately and one decision at a time. And the question is not whether you use AWS services. The question is whether you know which ones are commitments. Yep, and that rounds it up for me. All right, thank you so much.